So what we have here now is a miniature version of the Eratosthenes experiment. So again, we've got the curved surface of the Earth, and I've got this paper under it just so we can see the shadows more clearly in line with the curve. And when we shine a light on it, this is the kind of effect we get. We get shadows that do change in length and angle on this curved surface. But of course the heliocentric model has us with a very, very distant sun. So if I make that sun more distant and bring the shadows out, you can see that what actually happens is that the shadows do become more parallel, and they become about the same length, which is not what we see in reality. What we see in reality is a close sun creating shadows of differing lengths. Yeah, you can see that as I take the light source away, as is with the heliocentric model, then the shadows become the same length all across the Earth. That shouldn't happen. And if this light source was much, much bigger, we simply wouldn't get clearly defined shadows across the surface, because the light would be shining down all over the surface. So to actually have shadows with a distant and massive sun on a curved Earth simply isn't possible. Yeah? So that in itself debunks the Eratosthenes experiment and the idea that the results somehow prove that we live on a curved Earth, because otherwise we'd have either no shadows with a massive light source, or we'd have shadows that are always an equal length the further away the sun is. So let's just put this down on the... I'll take this away now, we won't need it. Let's just make a flat Earth Eratosthenes experiment, and we can see here that we get exactly what we need to get, and something that fits with our observations. With a local sun above this point here, we have no shadow, and we have those shadows getting longer and longer the further away they get from the light source. Like if I bring the light source over here, we can see these shadows, and this one's a short shadow, these shadows get longer and longer as they get more distant. And we can actually keep the light at the same distance above the surface, and as we take it further away, then those shadows just get longer and longer. Yeah? So this again fits with our reality. If you ever watch sunsets, watch the shadows at sunset, you'll see that they just get longer and longer until they fade into obscurity because the light isn't reaching them any longer. So again, a local sun on a flat surface with shadows of varying lengths and angles completely fits with the flat Earth, okay? And it doesn't work on a curved surface with a distant and massive sun.